Hello, welcome to another video of the class. In this video, we are going to focus on the third section of chapter 2, which helps us to study the product and quotient rules when we are taking derivative. Um, so when so basically we have learned about the derivative rules, and here we want to see how does the algebraic structure of a function helps us to taking the derivative, and how can we compute the derivative of product of two basic function, um, and also the quotient of two basic function. And then how do product and the quotient rules combine with the sum and constant multiply rules? We can combine them in order to quickly take derivatives. So just as a refresher, let me review that. So far we learned how to use derivative rules in order to differentiate power function, exponential function, and also two trig functions, sine and cosine. So since we already learned about the sum rule and the constant multiplier rule, we can also compute algebraic combination of these basic functions. So for example, let's look at the first example of this section. This function is given, and as you can see, it's the first part, 7x to the 11. This is a power function. Then there is a subtraction here, and here we have exponential function, sine function, cosine function. So it's a combination of basic functions that we learned. And we also learned that when we have such a combination, how to take the derivative. So as a warm-up, let me show you quickly how to take the derivative. So this is just the warm-up example. Sorry, just give me a moment to fix this. So example 1, we have the function 7x to 11 minus 4 times 9x, 9 to the power of x, plus pi sine of x. This is a trig function. And then minus square root of 3 times cosine of x. Okay, so this is the function, and we want to take the derivative of this function. So what we want to do is we are looking for the derivative of this function, and we are going to do that to find that using derivative rules. So what type is the first component? So this is a power function, right? This is a power function. Let's first identify each function. What type is this function? This is exponential function. 9 to the power of x. This is exponential function. And what type is this sine of x? This is a trig function. And finally, cosine of x is also a trig function. So we have an algebraic combination of these power, exponential, and trig functions. We know how to take the derivative of each one. For this algebraic combination, the only thing we need to pay attention is the sum rule and multiple constant rule. So for example, here you have 7 multiplied by this function. So it's going to be 7 multiplied by the derivative of this function. So just take the derivative of x to the 11, which is 11 x to the power of 10, right? So 7 times the derivative of this power function minus, okay, so on top we have 4 times exponential function. So the derivative is going to be 4 times the derivative of this exponential function. Derivative of 9 to the x is 9 to the x times natural log of x. Or maybe I don't need to put the parentheses, right? 4 times 9 to the x times natural log of x. So this is the derivative of, you see, so this is the derivative of this one. This is the derivative of this power function, right? Okay, so we go on. The next one, the operation is addition, pi times derivative of sine. Okay, what is the derivative of sine? Is cosine of x. Recall, derivative of sine is cosine of x. So cosine of x is the derivative of sine. And the last one, so first of all, there is a subtraction. The multiplier is a square root of 3. And then finally, we just need to take the derivative of cosine, which is negative sine of x. This is the derivative. So on top we have minus a square root of 3 times cosine. So we carry that minus the square root of 3 and we multiply it by the derivative of cosine. So there we go. If you would like to just, I mean, that's it. We took the derivative. If you just want to clean this up, you may rewrite it as the derivative is 7 times 11 is 77 x to the power of 10 minus 4 times 9 to the x times natural log of, oh, I'm sorry. This is natural log of 9. I mean, you can simplify natural log of 9, or you can leave it as natural log of 9. Let me see, how did your textbook, did it simplify? No, they leave it as natural log of 9. So I'm gonna leave it as the natural log of 9 as well. But if the question asks you to evaluate it, then you use a calculator to evaluate it. But here you can leave it as it is. Plus pi cosine of x. Oh, here, negative times negative gives me positive. Positive is square root of 3 times sine of x. And this is going to be the derivative of this function. So you can verify that with your with the answer that you have in the textbook. 77x to the 10 minus 4 times 9x ln of natural log of 9 plus pi cosine of x plus pi cosine of x plus a square root of 3 times sine of x. So this was a new. We already, in the first and second section of this chapter, we learned how to take the derivative of a function like this. That is a linear combination, algebraic combination of a power function, exponential function, and these trig functions. But how about a function like here? Look, you have z cube times cosine of z. Okay, so z cube is a power function, cosine is a trig function, and then we have them multiplied by each other. So this is a multiplier of two functions. We haven't learned how to take such derivatives. Or what about this function? Here we have sine of t divided by 2 to the t. So on top, so on this division, the numerator is a trig function, denominator is an exponential function. And we haven't learned, I mean, other than the limit definition of the derivative, we haven't learned a rule that gives us a shortcut to take the derivative of a quotient function such as this. So, so the goal of this section is to learn how to take derivatives of a product of two functions, or quotients of two functions, such as these ones. So I recommend you to go to look at the first activity of the textbook. So as you can see, f of t, a power function is given, g of t, another power function is given. So there are multiple steps. They ask you to take the derivative of each one and then compute a new function. So there are steps and that in these steps you compute something at each step, and then it wants you to give you some idea of product about the derivative of a product and quotient rule. So I recommend you guys to do this activity so that it prepares you for the product rule. And also I recommend you to read over this example, because in this video, we don't have the time to go over this example. The idea of this example is for you to show the proof of this rule, how this rule came from. But for the sake of this lesson, I'm just gonna state this product rule, and I'm gonna show you the application of this rule. If you are wondering where this rule comes from, I recommend you to do the first activity and then read over this argument. But let's see what is the conclusion. What is the rule about product of two functions? So the rule says that if you have two functions, f and g, two functions, both of them are differentiable, meaning that the derivative exists, then if you multiply them, so you create a new function, such as you call it p of x, you create a new function which is the product, the multiplication of these two functions, then you can use this formula in order to apply, in order to calculate the derivative. And I'm gonna state that rule here. Sorry. So the product rule. So here is the product rule. It says that you have two functions, right? F and G are two differentiable functions. And you want to take the derivative of a new function. That new function, let's call it p of x, is just the product, f of x times g of x. So product of these two functions. So the rule says that in order to find the derivative of this new function, just take the derivative. Let me be consistent with the order of your textbook. Oh, okay. So it says, if we want to follow the same order. So it's the first function times the derivative of the second function. So you, so in other words, f times the derivative of g plus derivative of the first one, derivative of f times the second function. Okay, so that's the product rule. So again, look, the rule, where does this come from? You can read the earlier argument, but what does it say? It says you multiply two function. Now you want to take the derivative. The product rule says that it's the first functions times the derivative of the second function plus derivative of the first function multiplied by the original function. So I'm going to show you the application of this in order to show you an example. So let's use this to answer this question. The product of z to the z cubed times cosine. So For example, so let's say P of Z is Z cube times cosine of Z. Find the derivative of this function P. That's the question. So first of all, let's identify this function. This function is a power function. Z cube is a power function, right? And then we have cosine, which is a trig function. And what do we have here? Here we have a product, multiplication. So the format of function P is the multiplication of a power function times a trig function. Now, what does product rule says? It says when you want to take the derivative, so it's gonna be the first function, which is Z cube, right? Times derivative of the second function. So I need to take the derivative of cosine of Z, right? So the first function multiply by derivative of the second function plus Now take the derivative of the first one. So now the first function is power function. Take the derivative of that and multiply it by the second function. That's the idea. Okay, let's clean this up. So it's gonna be Z cube times, what is the derivative of cosine? Negative sign. Plus, now take the derivative of the power function. What is the derivative of Z cube? It's 3 times Z squared. Multiply it by cosine of Z. That's it. So the answer is, we are done, but if you like to write your answer in a, I don't know, in a clean way, so you say the derivative is positive times negative, negative, Z cube times sine of Z plus 3Z squared times cosine of Z. So this is the derivative of this function. So what was the rule again that I applied here? I applied the product rule that says that you have the product of two functions. So it's the rule says that multiply the first function by the derivative of the second function added to derivative of the first function times the second function. Yeah, you can also check the answer with the answer we have in the textbook. So let's practice this. Let's do the second activity in order to practice this rule in couple of examples. So the activity says use the product rule to answer each question below. So the first part asks us to find the derivative of this function. Okay, so this is activity 2 of the section. The function is m of w. So w is the input variable. M of w is 3w to the power of 17 times 4. So I'm copying this. 4w, 4 to the power of w. Okay. And then, oops. Yeah, that's it. W to the power of 17 times 4 to the w. And the question is, find the derivative of this function. Okay, so let's Again, as always, first, let's identify the format of this function. So 3 is just a constant that is multiplied by the whole thing. So that's the number. But what is the next thing that we see here? W to the power of 17. So the input variable to the power of 17. This is a power function, right? Okay. And then multiply, sorry. So this is W. And then multiplied by 4 to the W. What is 4 to the W? 4, the number 4 to the power of, the power now is the input variable. This is, what format does this have? This is exponential function, okay? So we have, the 3, which is just the number. 3 multiplied by these functions, so you just carry that constant, you say 3 times. Now take the derivative, okay. So first identify the operation. What type of operation do we have here? Multiplication. We have the multiplication. What type of, M as a function. How can we describe M? M is a function that is the product, the multiplication of a power function by exponential function. So it's like we multiplied a power function by exponential function. So we can apply the product rule. Apply the product rule. What does it say? It says take the derivative of, take the first function multiplied by the derivative of the second function. So this is the second function, derivative, okay? And then add it to, now switch the position. The first one, derivative of the first one times the second function. Okay, so in other words, multiply one of the function by the derivative of the other one, then add it to, now switch their places. Take the derivative of the other function, multiply it by the other function. Okay, makes sense? Or if this is not clear for you, just give them name. Let's call this, if you cannot feel comfortable with this one, call this power function F and call this exponential function G. Then by product rule, you need to multiply F by G prime, and then, so maybe I write it down. So look, product rule says that, yeah, let me write it down. Product rule says that take the derivative of, it should be F times G prime plus F prime times G. So in case you cannot quickly come up with what to do in product rule, just write the product rule for yourself in terms of F and G. So one of them is F, the other one, call one of the function F, the other one G. Then it says F times G prime, meaning that the function F multiplied by the derivative of G plus F prime times G. Okay, so then in the next step, we just need to simplify, take the derivatives. So I need to copy, I just need to copy this, because W to 17, I don't need to do anything here. But for green one, for this exponential function, I am required to take the derivative, which is 4 to the W times natural log of 4 plus. Now I need to take the derivative for this power function. It's going to be 17 times w to the power of 16. And for this exponential function, just multiply by 4. So now if you would like to clean this up, it's going to be 3 times w to 17, 4 to w natural log of 4 plus 17 w to 16, 4 to the power of w. That is the derivative of this function. So we just apply the product rule in order to calculate this derivative. Let's do this one. This is h of t is sine plus cosine multiplied by t to the 4. Okay, so the function in B, the function in part B is h of t. Is it t? H of t is sine plus cosine. So it's sine function plus cosine function. So it's the addition of sine and cosine, but then it's multiplied by the function t to the power of 4. T to the power of 4, okay? And we need to take the, and the question is find the derivative. Okay, look, I'm gonna take the derivative of this function using the rules that we learned. So how can we describe function h? First, observe that h is this function, sine plus cosine, right? Times this function. So how can I describe that? The first one, this is a sum. This is a sum, addition of two trig function, right? So I have sum of two trig function multiplied by a power function. And we have the product, right? We have the product of these two functions. Okay, so the first rule that I need to apply is product rule. Okay, so the first thing is product rule, which says that take the, so what does product rule says? It says just state the first function, which is sum of this function, and then multiply it by derivative of the second one. Okay, plus. Now take the derivative of the first function and multiply it by the second function. So here in this step, I just applied, here I applied the product rule. Okay, nothing else, just product rule. So it's gonna be, so we need to copy this, sine of t plus cosine of t. And then what is the derivative of t to the 4? It's 4 times 3 cubed. And then now we need to take the derivative of this function, the sum function. Okay. So recall how to take the derivative of the sum function. You take the derivative of each one. So I need to take the derivative of sine, which is cosine. Take the derivative of cosine, which is negative sine, and that's it. So this is gonna be the derivative of this sum function and multiply it by the power function. So that's it. That's the derivative. If you would like to, I don't know, simplify further, you can, but basically that's it. Okay. So again, we started with the product of two functions. One function is the summation of trig function, and the other one is power function. So we need to apply the product rule, which says the first function times the derivative of the second function. So that's why I put the prime here. Take the derivative of the second one plus derivative of the first one. So we take the derivative of first one and we multiply it by the second function. So in other words, here in the first component, we took the derivative of the power function. In the second component, we took the derivative of the sum of trig function. Here, you see that? So that's it. Part C, determine the slope of the tangent line to the curve of f at the point where a is 1 if f is given by this rule. Okay, so first of all, function f has this formula, e to the x times sine of x. So let me first copy that. This is part C. Part C. What is f of x? F of x is e to the x times sine of x. So that is the function. Now the question asks for the slope of tangent line to the graph of this function at 1. So we need to find a slope of tangent line to the graph of f at x equal 1. That's the question. At 1, exactly. So first recall that a slope of tangent line at a given point is the same as, this is the same as f prime, the derivative. So what the question is asking us, which is the slope of tangent line, is the same as f prime at 1. So a slope of tangent line to the curve at 1 is the same as derivative of the function at 1. So we need to find f prime of 1. So how to do that? Let's first find, so first we find f prime of x, a formula for the derivative, and then we evaluate f prime at 1. In this way, we can find the answer. Okay, so the first step is, just find the derivative. So let's take the derivative of this function. Again, f of x is e to the x times sine of x. Let's determine the format of this function. It is e to the x. What type of function is this? E is a number to the power of x. X is the input variable. So this is exponential. This is exponential function, right? What about sine? Sine is a trig function, right? So we have the product, we have a multiplication, a product of an exponential function and a trig function. So we need to apply the product rule. Just apply the product rule. So what does it say? Product rule says that the derivative of the function, of the product function, is the first function times derivative of the second function. So we need to take the derivative of second function plus derivative of the first one, times the second function. Okay, so first times the derivative of the second plus derivative of first times the second function. Okay, so in the next step, we just need to evaluate these derivative because they are basic function. We know how to take that derivative. Derivative of sine is cosine. Derivative of e to the x is e to the x. Recall that derivative is e to the x. So again, what is cosine of x? That's the derivative of sine of x. What is e to the x here? That is the derivative of e to the x. Okay, that's it. We got it. The answer is, the derivative is e to the x times cosine of x, e to the x times sine of x. That's the derivative of this function. So we are done with the first step. The first step was we need to find the derivative of this function. Now, the second step says evaluate that derivative at value 1. So that means substitute 1 into this equation. So it's going to be e to the 1 times cosine of 1 plus e to the 1 times sine of 1. You can leave your answer like that. Or you can, depends on, so sometimes the question asks you to leave your answer like this, or sometimes it asks you to evaluate it in terms of, so this is the answer. This is the answer, okay? The slope of the tangent line at this point. You can leave it like this, but if the question asks you to like simplify it, then you need to go to scientific calculator to evaluate cosine of 1 and sine of 1. For example, what do you need? You need cosine of 1. Then depends on, and you need sine of 1. So you see, you get decimal, and then usually if the question asks you to enter your answer as a number, then they tell you to how many decimal you need to round this up. So in case the question asks you to like round it or evaluate it, then you use the scientific calculator in order to simplify this. Otherwise, you can leave your answer like this: e times cosine of 1 plus e times sine of 1, which is the answer to this function. Okay, and the last part asks find the tangent line to this function g at point -1, and g is given in this format. Okay, so g here, the function g, this is part D of the activity. G of x, the function g has this formula. So x squared plus x, and then the whole thing is multiplied by 2x. So x squared plus x times 2 to the x, right? X squared plus x times 2 to the x. Okay, so that's a function. This is function g. The question is, find the tangent line to the graph of this function at -1. Okay, so find the tangent line to the graph of g at x equal -1. So you know that when we want to find the equation of a line, we need a slope. So we need a slope of the line. First, we need the slope. Second, we need y-intercept. The y-intercept. When we have these two elements, then we can write the equation of tangent line. So first, how to find the slope? Recall that the slope of tangent line, to the graph is the same. So the slope of tangent line to the graph of g at -1 is the same as the derivative of the function at -1. So to do the first step, we need to find g prime of -1. So we need to find g prime of -1. So first, let's calculate g prime of x, okay? So we need the derivative of this function. So the function is defined as this format, and we need to take the derivative of this function. We need the derivative. To do that, first we need to identify the format of this function. Pay attention that this is a summation of sum of power function. So you have a sum of power function times what is this? Exponential function. Okay, so we have what? We have the product of these two. So we need to apply the product rule. What does the product rule says? It says just copy the first function and multiply it by the derivative of the second function. So take the derivative and put it here. And then add it to. Now, it's the turn for first function. Take the derivative of the first function, take the derivative of the first function, and then multiply it by the second function. So in the next step, we are going to take these derivatives. Okay, what is the derivative of 2 to the x? Derivative of 2 to the x, because this is exponential, is going to be 2 to the x times natural log of 2. So this is just the derivative of 2 to the x plus. Now take the derivative of this function, x squared plus x. So this is a summation. Take the derivative of each one. What is the derivative of x squared? 2x. What is the derivative of x? 1. So just add them. So this is just the derivative of 2x plus 1 is the derivative of x squared plus 1. And then multiplied by 2 to the x. So if you want to write this in a clean way, we say, that's it, but I'm just cleaning this up. It's x squared plus x times 2 to the x times natural log of 2 plus 2x plus 1 in the whole thing, the summation of 2x plus 1 times 2 to the x. So this is the derivative. So we used a product rule and we took the derivative of the function. And what do we need for the slope? In order to find the slope of tangent line, we need to evaluate g prime at -1. So I need to evaluate g prime at -1. Maybe I used another color. Sorry. So we need to evaluate g prime at the value of -1. Okay, so that means for x, you just need to substitute -1. So it's gonna be -1 squared plus -1, you see, times 2 to the -1, natural log of 2. So maybe I just use the blue color because I didn't substitute. Okay, natural log of 2 plus 2 times -1 plus 1 times 2 to the power of -1. You see that? So we just substitute -1, and you can simplify that for g prime of -1 is gonna be, so this is gonna be -1 squared is 1. 1 minus 1 is gonna be 0. 0 times anything is gonna make it 0. So the first one is 0 plus 2 times negative 1 is gonna be negative 2. Negative 2 plus 1 is gonna be negative 1. So it's gonna be negative 1 times 2 to the negative 1, which is gonna be negative 2 to the negative. You can either say 2 to the negative 1 or you can flip it. Recall that this is the same as half. So g prime of negative 1 is negative half. So that's it. That's the slope. We got the slope. So what is the slope? Negative half. Negative half. So we did the part 1. We found the slope. Now we need to find the y-intercept. To find the y-intercept, recall that let's start with writing the equation of the line. We are looking for the equation of tangent line. So what is the general format of equation of line? Y equal mx plus b. So in this case, y equal m is half, negative half, x plus b. So we just don't have the b, the y-intercepts. Again, recall that when we are looking for y-intercept, it's enough if we just have one point of this line, and then we can substitute the coordinate of that point into the equation and solve it for b. So because this is a tangent line, graphically, recall that graphically, so suppose this is the graph of the function, right? And then suppose this is the tangent line, right? Suppose this is the tangent line. So then at this point, so this is, let's say this is negative 1, for example. So this point, the intersection, which has the x value of negative 1 and the y value is g of negative 1, belongs to both of them. You see, this point, negative 1 as the input and g of negative 1 as the output. This point belongs to the graph of the function and belongs to the tangent line. It's the intersection point. So definitely negative 1 and g of negative 1 is a point that satisfies the equation of line. So that you can use that. So let me here evaluate that. So again, g of x is, what was g of x? X squared plus x times 2 to the x. So we are looking for g of negative 1. It's going to be negative 1 squared plus negative 1 times 2 to the negative 1. This is going to be positive. 1 minus 1 going to be 0. 0 times anything is going to be 0. So the point is negative 1 and g of negative 1, which is 0. Okay? So the x value is negative 1, y value is 0 for the input value of, so I'm going to substitute here. I'm going to substitute this point here. When the input value is negative 1, the output value is 0. So you substitute that into the equation and then you solve it for b. So it's going to be positive half plus b. So b is negative half. Okay. That's it. So we also found b. So the answer is, the question is fine. So a big picture. We also found the y-intercept. So now we can write the answer. The answer, which is the equation of tangent line, is y equal, what was the slope? Negative half times x plus y-intercept, which is also negative half. That's the answer. So you have seen questions like this in the past, finding the equation of the tangent line at a given point. So that part is not easy because you know what is the equation of line, you know you need the slope, you need the y-intercept. finding the slope is the taking the derivative at that given point. So you know all the technique. The only new part was the steps that we need to apply the product rule here. These steps that we needed to apply the product rule in order to, so we use the product rule in order to take the derivative. So just that part was the new part, but otherwise you have seen questions like this in the past. Okay, so that's all about product rule, and I think now you should have be ready to do some practices for that. Before ending this section, we want to look at another rule, which is quotient rule. When you have a function that is a division, of two function, and actually to come up, I would like to ask you something. So once you have I'm going to give you an exercise. It's good practice for you. Once you have a function that is division, so suppose you have f of x, you have two functions, f and g, and you divide them. So both of f and g are differentiable, meaning that the derivative exists. And you use these two functions to create a new function. You do the division, you divide these two functions, and you create a new function. Let's call it q of x. This division, this quotient, give you a new function. Now the question is that, what is the derivative of this? So we don't know that. We actually can come up with the formula, but at the moment, we don't have a rule for that. But since division is derived by multiplication, I would like to ask you guys to practice this. Look, you can rewrite this equation, right, in a way that, say, 1 times f of x is q of x times g of x. And then apply the product rule, take the derivative of f. Because here you have multiplication, so you apply the product rule. So it's going to be q of x times g prime plus q prime times g. So pay attention that what do we want to find? We are looking for q prime. And actually here, I got in this equation, I see the q prime. So let's solve this equation for q prime. So it's going to be f prime of x minus this term equal q prime of x times g of x. Now, how can I have this q prime of x by itself on one side? Just divide both sides by g of x. So divide both sides by g of x. So that's going to give me q prime. Right? Okay. So I was able to come up with something for q prime, right? So actually that is also here in your textbook, that if we rewrite this equation in a way that we have a function as a product of two functions, and then we apply the product rule, and then we solve this equation for q prime of x, then we are going to end up with this formula. And now recall that what is q? Q is a function that is the division of f and g. So the point is that, look, now I have what I want. Look, we are looking for q prime of x, right? And I have it all by itself on one side. So when we want to give a rule for any type of operation. Because the original function is based on f and g, so that rules must only contains f and g or anything related to f and g. So I know f, so I can calculate f prime. I know g, I can substitute g here. I can calculate g prime. But you see that here, instead of fg, we have q and x. Technically, in fact, you can leave it like that. But now just let's rewrite q as the quotient of f and g to get a nice format. So the only idea is to get a nice format. So rewrite q as f divided by g, and then simplify it. So in this formula, we just substitute q of x by its definition, right? So if you take a common denominator on top, so this is the big division. And on the numerator, take the common denominator. So it's gonna be g of x times f prime of x minus f of x times g prime of x. And then the last step, if you simplify that, you get the top over denominator. G of x times g of x give me g squared, g of x squared. And that's the clean formula for the derivative. So that's it. We just proved the quotient rule. This is called the quotient rule. When you have the function q of x as the division of f and g, we show that how can we derive this formula, which is called quotient rule. So let's summarize it. If f and g are two differentiable functions and q is their quotient, and if the quotient is also differentiable, then this gives you the formula for the derivative of q. So the derivative of q is gonna be g times f prime minus f times g prime divided by g squared. Now, in terms of, so look, when if you call numerator and denominator by functions, like let's say q is f over g, f divided by g, then you say g times f prime minus f times g prime divided by g squared. But the idea is that whatever function, regardless of their name, whatever is the function on the numerator divided by denominator. So you have the denominator multiplied by the derivative of numerator minus numerator times derivative of denominator over denominator square. So it's up to you. If you give these numerator and denominator a name, such as f and g, then you can say g times f prime, whatever way that is comfortable for you. So I'm going to show you an example. In this example, we are going to apply this quotient rule. So we are going to do example 3 using the quotient rule. The function in this question is sine of t divided by 2t. So q of t is sine of t divided by 2t. Because this is our first example, I'm gonna use the same format that the rule is given here. That suppose q is f divided by g. Okay, so here the format of q is f. Let's call this f. Let's call the function. So first of all, observe that we have a division of a trig function, right? Which we call it f. We are going to call this f, and over what type of function is this one? This is exponential function. And we call it G, just for the sake of using the quotient formula. So the question is, find Q prime of T, right? That's the question. What is Q prime of T? So by quotient rule, we know that this is gonna be G times F prime minus F prime times G over G square, right? I'm just copying the quotient rule. G times F prime minus F times G prime over G square. G times F prime minus F prime times G over G square. And by F and G, you know, I mean the function. So maybe I rewrite it. By F here, I mean sine of T, the function in the numerator. By G, I mean the function in the denominator, 2 to the T. Okay, so let's just substitute those values. So this is gonna be G. What is G? G is 2t, 2 to the power of t, times, what is F? F is sine of t, and we need to take its derivative, minus F, just sine of t, times G. Oh, I'm sorry. I didn't copy this correctly. This must be G times F prime, F minus F times G prime. Okay, F times G prime. Okay, divided by G square. G is 2t square. Okay, so in the next step, I'm going to take these derivatives. So it's gonna be 2t, 2 to the t times. What is the derivative of sine? Negative cosine. Oops, I'm sorry. Negative cosine. What is the, and minus sine of t times, take the derivative of 2t. Derivative of 2t is gonna be 2 times t times natural log of 2, right? Divided by 2, okay, t to the power of 2 is gonna be 2 times t. That's it, that's the derivative. If you like to clean it, you can rewrite it to make it cleaner. It's gonna be negative times positive is negative. So negative 2 to the t times cosine of t. Here minus, sine of t times 2 to the t times natural log of 2 divided by 2 to the power of 2t. That's it. So here we applied a quotient rule. The big picture is right here. We applied the quotient rule and we calculated this derivative. And you can see that here as well. So in your textbook, it says that the derivative is gonna be g, or the denominator, times the derivative of the numerator minus numerator times the derivative of denominator, and then denominator square, which is gonna be, oh, we can simplify further, by the way. So your textbook, so that's it. So this is it. But if you compare this answer to the answer in your textbook, is that they simplified it further because numerator and denominator has 2t in common. So I'm going to show you that as well. So if you like to simplify this further, you can factor 2t from numerator. So it's going to be, and you can factor wait a minute. Why do I have negative sign? I'm sorry. I just need to fix something here. I said the derivative of this sign is negative cosine. My bad. It is cosine. It is positive. So this is positive. My bad. This is not negative. Negative derivative of sine is positive cosine. Okay. So we factor 2t. So it's gonna be cosine of t minus sine of t times natural log of 2 over 2 t square or whatever. So when you cross that, you're gonna end up with cosine of t minus natural log of 2 times sine of t over 2t. So that's it. So in the textbook, they simplified it further, meaning that they factored 2t from the numerator and it was canceled with one of the 2t in the denominator. And this is the final answer. Okay, so in the next activity, we are given a couple of examples. And the question asks us to practice the quotient rule. I'm going to show a couple of them to you, and then you can do the rest perhaps. Okay, so let's look at part A. So this is activity 3. So this is activity 3, and I'm doing part A. Part A says R of Z is a quotient of, what is on the numerator? On the numerator, we have 3 to the power of Z, 3 to the power of Z. And on the denominator, we have Z to the 4 plus 1, Z to the power of 4 plus 1. Okay. And the question is find the derivative of this function. So you see that this is a division. This is a division. So I'm gonna give them a name and use this name in order to take the derivative. So let's call the numerator F, the denominator G, just for the sake of a product rule, because I'm gonna copy the product rule. So what is product rule? Product rule says that R prime is gonna be what? It's gonna be G F prime minus F G prime divided by G square. That is the product. Oh, I'm sorry, not product, quotient rule. That is the quotient rule, right? The quotient rule. G times F prime, F times G prime over G square. Quotient rule. Okay. So now let's do it. So it's gonna be R prime of Z is G. Copy the function in the numerator times F prime. What is F prime, by the way? Let's calculate F prime here. F of X, so F is 3 to the Z. So what is F prime? F prime is 3 to the Z times natural log of 3. So 3 to Z times natural log of 3. Okay, minus F, what is F? 3 to Z times G prime. Okay, what is G prime? So what is G? G is the function in the denominator, Z to the 4 plus 1. What is G prime? G prime is 4Z cubed. So it's gonna be 4Z cubed. Okay, so this is just G prime. See that? And this right here is just the F prime. See that? And finally, we put G square. G square. You can leave your answer like this, or I don't know, if you want, you can simplify further, but that's it. That's the, so you see, we just use the quotient rule and we calculated the derivative of this function. Maybe I show you one more. So I'm going to show you B, and then I'm going to leave C and D for your practice. So I'm going to show you part B of this activity. Part B says the function is V of t is sine over V of t is sine function over, what is the denominator? Denominator is cosine plus t squared. So it's cosine of t plus t squared. Okay, so this, you see that this is a division. So we need to apply the quotient rule in order to calculate the derivative of v prime of t. What is v prime of t? Okay, so again, for simplicity, let's name the function, and so let's name this f, and maybe let's name this as g. So when we apply the quotient rule, we can simply refer to them. So what is the quotient rule again? Quotient rule, maybe I use another color. Quotient rule says that the derivative is denominator g times f prime minus f times g prime over denominator square. So that is the quotient rule, the rule that we are going to use in order to take the derivative of this function. Okay. So it's gonna be v prime of t is gonna be g. What is g? G is cosine plus t squared times f prime. So let's calculate f prime. Okay, f is sine function. So its derivative is cosine. So I'm gonna put cosine of t, okay? So what is this? This is just the derivative of f minus f, which is sine of t, times g prime. What is g prime? If g is cosine plus t squared, then g prime is gonna be derivative of sine, which is negative, derivative of cosine, which is negative sine, plus derivative of 2t squared, which is 2t. So g prime is negative sine plus 2t. So this is g prime, okay? So g prime is right here. This is g prime. And f prime is right here. And in the denominator, we put g square. Okay, that's it. So if you like, you can distribute and simplify. Otherwise, that's it. That's the derivative. Let's look at this in a big picture. Okay, so the quotient rule says g times f prime. So you have g times f prime, which is right here, minus f times g prime. G prime is right here, and then over g squared. So not too hard, just follow the rule in order to take the quotient derivative. Okay, the last section, which I'm gonna go over it more quickly, is combining the rules. So that's the case when you have a function such as here, that part of it is product, part of it is quotient. So, and you have a linear combination of that. If you learned how to take the derivative of, if you learn the product rule and quotient rule, this part is just nothing. This part is so easy. I'm going to show you how to combine these rules using this, the fourth example. So look at this example. So this is example 4 of the textbook. And the function is f of x is x times sine. F of x is x times sine of x plus. And then we have a division. Numerator is x squared. Numerator is x squared. Denominator is cosine of x plus 2. Cosine of x plus 2. The question is find the derivative, right? Now, recall that every time that we need to take the derivative, we first need to identify the format of this function. Pay attention that here we have this function, this part, which is a product. This is a product. Why? Because we have x times sine of x. So we have the product of a power function and trig function. So we have a product of two functions, and then we added that. So here we have the sum. So we added that to what type of function? The next one is just a quotient, right? This is a quotient. Quotient of, so this is a quotient of what type of function? Power function over a trig function. So look, let's go step by step. So first of all, we have a summation here, right? We have an addition. So that means take the derivative of the first component, right? So I'm going to use this notation. So take this derivative. So by prime, I mean to the derivative. Take the derivative because of the sum, because we have the addition, right? Just take the derivative of each function and then add them together. Okay. No, not this color. It was this color, right? Because we have the summation, right? So because we have the summation of two functions, so apply the sum rule. Apply the sum rule. What the sum rule says? Says take the derivative of this function, add it to the derivative of the second function. Okay. So we are going to do that. We are going to take the derivative of x times sine of x, and then add it to the derivative of x squared over cosine of x plus 1. Okay, so I need to take the derivative of each one. So how can I take the derivative of first one? This is a product, right? This is a product of x times sine. So this is the product of power function and trig function, right? So I need to apply the product rule. So that's gonna be derivative of, so it's gonna be first, right, times the derivative of the second function, which is cosine, plus, now, derivative of the first function which is 1. Maybe I need to write in, because this is the first example, maybe I write in more steps. Okay, I'm gonna write more steps. So it's gonna be the first function times derivative of the second function plus derivative of the first function times the second function, right? Before getting to quotient, I'm gonna simplify this. So it's gonna be x times cosine of x. Now, what is the derivative of x? It's 1 times sine of x. Okay. Now, let's plus. Now let's take the derivative of this quotient. We are done with the derivative of the first part. We are done with this. Now we should take the derivative of the quotient. Because it's the division of two functions, so we need to apply the quotient rule, which says it's, recall that it's numerator, sorry, it's the denominator times derivative of the numerator minus the numerator times the derivative of the denominator over denominator square. So that's the quotient rule. Now, in the next step, I'm gonna simplify those derivatives because, okay, so I'm gonna copy cosine of x plus 2 times. What is the derivative of x squared? It's 2x minus x squared. Now I'm gonna take this derivative, this one. So it's gonna be, cosine is gonna give me negative sine of x, and derivative of 2 is 0 over cosine of x plus 2 square. So that's it. We already applied the quotient rule and the product rule, and we just, you can either leave your answer like this, or if you want, you can simplify the final answer. So I'm gonna simplify as much as possible. So f prime of x is gonna be x times cosine of x plus sine of x plus, plus, so that's the plus, right? Plus, okay, what about here? Cosine of x plus 2 squared is the denominator. On top, I have cosine of x plus 2 times 2x. Negative times negative give me positive x squared times sine of x. Okay, that's it. So this is the derivative of this function. So in this example, you saw that basically we are not doing anything new. We are just combining what we learned. What rules did I combine here? Product rule, sum rule, quotient rule. So we started with the sum rule. What the sum rule says? It says sum of two functions. You want to take the derivative of sum of two functions. Take the derivative of each one and add them all together. Okay, so that's the first step we did. This is the first step, right? First, we took the derivative of each function and then we add them together. Now, looking further at this function, we realize that, okay, one of them is the product of two functions, so we apply the product rule. The other part was the quotient of two functions, so we apply the quotient rule to finally get the final answer, okay? So nothing new, we just need to, and by the way, in my writing on the board, I use prime just to explain the notation. When I want to, in my writing, when I wanted to express derivative, I put prime on top of the function to mean derivative. So sine x prime. So when I say here sine of x prime, I mean derivative of sine of x, which is cosine of x. In your textbook, if you read the example through your textbook, you see this notation, d of the function, you see d over d of x. D over d of x is a notation for derivative. So when you see d over d of x, it means derivative of whatever is in that bracket, derivative of this. So for example, the first step says that, okay, we need to take the derivative of this function, the whole thing in the bracket. And then it observed that because it's addition, so we need to take the derivative of the first one, add it to derivative of the second one. So for the word derivative, it used the notation of d over d of x. So whenever you see this notation, that's just the same as the prime notation that I use, which stands for taking derivative. I'm gonna also show you example 5, and then perhaps yes, I leave the activity for you. So let me also show you example 5. Okay, example 5. Is the function s for input value of y is defined as the quotient of y times 7 to the power of y over y squared plus 2, y squared plus 1, sorry, y squared plus 1. So this is the function, okay? This is the function. Now, what's the question? Okay, so, oh yeah, the question is find the derivative. Okay, find the derivative. Find s prime of y. So you see that when you want to take this, let me show you. The first thing I observe is that look at the format of this function. The format of this function is the division, is the quotient of two functions. It's the quotient of this function, right? So I think here it would be easier if I name them. Let's give a name to this. Let's call this f, and let's call this g. Maybe I use another color, g. Yeah, I think in this example, it would be easier if I give them a name, just for the sake of using the quotient, rule. What does quotient rule says that? It says the derivative of quotient of two function is the denominator g times derivative of numerator f prime minus numerator times the derivative of the denominator, and denominator square. So that's the quotient rule. So I'm just writing the quotient rule here. Okay, now just so if I want to use the quotient rule, I need the f prime and g prime. So before going to quotient rule, let me calculate f prime, let's calculate f prime and g prime. So what is f? F is y times 7 to y, the numerator. Let's calculate the derivative of f. Okay, let's take this derivative. So what is the format of this function? It's the product, you see? It's the product of two functions, y times, you see? It's the product of this function it's the product of this function, which is a power function, and this function, which is exponential function, right? So apply the product rule. So we need to apply the product rule here. So what does product rule says? It says it's gonna be derivative of the first. So I need to take the derivative of the first one and multiply it by the second one. Oops. Plus derivative first times the derivative of the second. Product rule. Okay? So let's do it. So derivative of y prime is gonna be, or maybe I just rewrite it in this first, in the equation. So I'm taking the derivative of the first one. What is the derivative of y? 1. And we are taking the derivative of this guy, 7 to y, exponential function. It's gonna be 7 to the y times natural log of 7. Okay, so f prime of y is 7 to the power of y plus y times 7 to the y times natural log of 7. That is f prime. Now let's calculate g, because I also need g prime. So what is g? G is the denominator is y squared plus 1. So take the derivative. It's gonna be 2y. This one was very easy and straightforward. Okay, now we just need to substitute these into our quotient rule. Now that I have the f prime, I have the g prime, we can just substitute them into the equation. Okay, so what is g? G is y squared plus 1. What is f prime? We just got f prime right here. So it's 7 to the y 7 times 7 to the y natural log of 7. Okay, so f prime is right here, minus f y to the times 7 to the y times g prime. G prime is right here, 2y. This is g prime. Over g squared. G is y squared plus 1 times the square. You can leave your answer like this, or you can simplify further, but that's it. Okay, so here, from here to here, I'm just doing quotient rule. You see, I'm just applying quotient rule. But inside that, you know, because I need f prime and g prime, derivative of numerator and derivative of denominator, I needed to apply other rules as well, such as product rule or sum rule. So inside this calculation, I needed to apply sum rule, product rule, but eventually, because this is a quotient rule, everything needs to be substituted into the formula of the quotient rule. By the way, again, your textbook, let me go over the notation of textbook. The notation of d over dy stands for derivative. So your textbook is stating the quotient rule here. So it says that the derivative of this function is the denominator, you see, denominator, you copy the denominator, times derivative d over dy of the numerator minus numerator, which is copied here, times derivative of denominator over denominator square. And in the next line, here, yes, in the next line, it takes the derivative of the numerator. So this bracket is just the derivative of the numerator, which is the same as what we have here. We calculated that over here, and then it's substitute into the function, into the rule, and then also the derivative of denominator. So I just wanted to show you that you can use prime or you can use the notation, but either way, it doesn't matter what notation you use, as long as you have an understanding of this rule and you apply this rule carefully, it doesn't matter. So I leave the next activity for you in order to practice. And here is a summary of what we learned in this video. We learned the product rule, and we learned the quotient rule. And I encourage you guys to do these exercises. The first exercise is just the derivative of a basic product. So here you just need to apply the product rule. I encourage you to do not look at the solution. Do this problem, enter your answer here, check your answer, and in case it doesn't match the correct answer, then click here in order to see the solution, okay? So I encourage you guys to do these exercises, do this question, and then again, you can click here to check your answer with the correct answer. So the first one is just the basic product rule. The second one is more complicated function that needs you to apply the product rule. This one is a derivative of quotient, but numerator, the type of the function in numerator and denominator is just a linear function. This is, you have a power function, so you need to apply quotient rule. On top you have power function, on denominator you have linear function. Here you have product of two trig function. Here you have a product of power function and trig function. Here you have sum of two trig function, and more question and example. I strongly encourage you guys to do these exercises because they're gonna be a good practice for you to get a good grasp of this section, and also become ready to do the homework assignment of this section. Okay, that's the end of this section. Thank you for watching this video. I'll see you in the next video.